My name is Bernhard Fraxon Masebo. I'm a senior mathematics teacher holding bachelor degree of education in science, majoring mathematics. I'll be here sharing with you mathematics in particular to advanced level, that is Form 5. We need to know in short that advanced level a student will complete when he will be doing an exam which is having paper 1 and paper 2. And paper 1 is taking 10 topics, whereby each topic is comprising 10 marks per question. And then we have paper 2, which also have 8 topics. But to begin with, I will be concentrating to Form 5 topics. To begin with, Form 5 is having topic of mathematical device. We have algebra, we have set, we have the topic of logic and electrical network, we have the topic of coordinate geometry 1, we have trigonometry, we have another topic of linear programming, and then we have the topic of differentiation, and then we have integration. So today I'll be teaching you the topic of algebra. As you can see here, we have written the word algebra. To begin with, in this topic of algebra, we will need to know these subtopics here. So in algebra, you will need to have the concept of exponent. We will also have to know the concept of logarithms. We will need to have the idea of the part of series. We will know the idea of Pascal's triangle. And then we will have to catch up the knowledge of binomial theorem. And then from there, we will check the technique and the idea of polynomial function. And then we will be finishing with the part of matrices. In these parts, each part will be taking several components and some explanation and the hints which is appearing in the part. Now to start with the part of exponents. We covered the concept of exponent when we were in Form 2, and for sure it was easily explained that when you have a number, let's say 2 times 2 times 2 times 2, this was the same as to write as 2 power 4. You know why? We are writing like this because a number has been multiplied repeatedly 4 times. That is why we just put the base, this 2 raised to 4. 4 signifies how many times 2 has been multiplied. So in this juncture here, class, we always say this 2 is the one termed as base, and this 4 is the one termed as exponent, where its plural is always called index. We call it as the index. As far as the level of the study is concerned, which is a Form 5 student, we will be not taking a lot of time trying to exhaust about the concept of what is an exponent and what is a base. So here, class, we will be much concentrating on the part for rules for exponents. So today I'm going to explore a lot. That is a part of rules of exponents. Class, when we were dealing in Form 2, we were given some multiplications of powers in which you were given a number like 2 power 6 times 2 power 3, let's say. One could have to take these 2, multiply itself repeatedly until 6 times, and then continue connecting with multiplying with this 2 power 3 again, then you could check out the total 2's appearing from the beginning up to the end. But that is not the case today. Today we are just going directly trying to analyze the rules. So here we call rule number 1. Rule number 1 we call the law of multiplication. The law of multiplication. The law of multiplication. Multiplication. Here we say, suppose you are given, suppose we have 2 power 5 times 2 power 3, let's say. One could just take like this. You could just proceed as, we say, we proceed as 2 times 2 times 2 times 2 times 2. We are using dot to ease the multiplication instead of using times. And then here grouping this as the first group, and then connecting with the second part, which is 2 times 2 times 2. And then here making another group. When you try to counter from the beginning up to the end, you could find that it is the same as to write as 2 power 8. Checking carefully, this 8 class is simply as the same as to say 2 power 5 plus 3. Now, what do we deduce from this part? We simply deduce that when multiplying a number of the same base, we simply add the exponents. So we say generally we say a power m times a power n is the same as to take as a power m plus n. So this is one of the most important rule, and we will be working with this rule by solving some questions in which we will be applying the rule. So we call rule number 2. Rule number 2. We say the law of quotient, or the law of division. The law of division. The law of division is not that much different from the law of multiplication. It is just when we have been given an expression like suppose we are given, suppose we have 2 power 4, let's say divide by 2 power 2. Mathematically, there exist 2 approaches which holds for the student to tackle this problem. So here we say, here we proceed as here to operate this. We proceed as approach 1. One could take like this. One could take 2 times 2 times 2 times 2. Then you could make a division, but then you have 2 times 2. You know why? It is simply because 2 is related to exponent 2. That is why 2 appearing twice. So we could make the law of cancellation where you could find this 2 is cancelled with this 2, and this 2 is cancelled with this 2. And then finally at the numerator part, at the upper part we could be having this result, which is 2 power 2. So we say, this is the first result. We have got 2 power 2. So we say, what does this signify? It signifies that a power m divided by a power n is the same as to take a power m minus n. Because you can see these 2, it means it was the same as taking 2 power 4 minus 2. Because we have just treated the exponent, the index one, as the one which we have operated. So this is one of the most important rule also. We are going to work on this one. Thank you very much. And then we proceed. With this second rule, we can see rule number 3 here. Rule 3 here, class. We say the law of zero exponent, we call. The law of zero exponent. Zero exponent is nothing, just to be given an expression here like suppose we have 2 power 3 divided by 2 power 3, let's say. Here, we treat like this. We treat as with approach 1. With approach 1 here, class, it could be simple like this. We could just take 2 times 2 times 2, and then divide by 2 times 2 times 2. This is simply because we have been dividing by using the long division method, making this the slashing line. But you can make cancellation from the law of cancellation. That means these 2 will cancel with these 2. Similar also here. And finally, so here, class, if you check carefully, you will find that there exists all cancellation from the numerator and the denominator, which ends with the result of 1. A student or a person learning mathematics will accept that this result is mathematically true because the cancellation has been taking place. But there is another one who could apply another technique. We can call it as approach 2. Let's say call approach 2 here, class. Approach 2, one could be using rule number 2, dividing the numbers in which base are the same but different exponent. We could just take it as 2 power 3 minus 3, which is the same as 2 power 0. You know why? We say when we divide numbers of the same base, we will simply operate for the indices. That is to take 3 minus 3, which means gives 2 power 0. Now, what does this signify? It signifies that the result in approach 1 and 2, they all hold in mathematics because they are all valid approaches. So this is the same as to say the result here where one has got 1 and another is getting 2 power 0, they all the same mathematically. So we could write thus 2 power 0 is the same as to write 1. Now, what is the conclusion? So we say generally a power 0 equals to 1. So one of the most important rules. Now we are going to pose some questions. Here we say clearly, if I take 2 power 0 is 1, I take 3 power 0 is 1, I take 7 power 0 is 1, I take negative 1 over 2 power 0 is also 1. But when you take 0 power 0 is undefined. So we give the question, do you think why? Because we know any number power 0 is 1. But when one is taking 0 power 0, we say is mathematically undefined. So that is where the question arises. We say, is 0 a number? We ask ourselves, is 0 a number? Now someone will say, yes, 0 is a number. Now we ask, why, if 0 is a number, why does not hold to take 0 power 0 giving a number 1? Why is giving undefined if we say 0 is a number? And one will say, no, 0 is not a number. Then we will ask ourselves, if 0 is not a number, why when you count whole numbers, you always start from 0? Now, this is a question for thinking and brainstorming. I will come, we will be meeting for the next time, I will be waiting for students to respond for these questions. Okay. We are now able to check for rule number 4. Rule number 4, this is about negative exponent. Negative exponent. Student, have you ever been come across with this term, negative exponent? Do you think how it appears when we talk about negative exponent? It is for sure that when we talk about negative exponent, it means we can just deduce this from the rule here. And here we say, suppose we have 2 exponent 3 divided by 2 exponent 5, let's say. Here, we proceed as, we could treat like this. We could go with approaches as usual. When you take approach 1, you could be simply taking as 2 power 3 minus 5, just giving you 2 power negative 2. You know why, class? It is simply because we always take the exponent, treating the index alone, where you have been given 2 power 3 divided by 2 power 5. So we simply take 3 minus 5, which is now giving negative 2. Now, mathematically, this approach holds. Now, we're taking approach 2. Another learner of mathematics could say, why don't we take 2 times 2 times 2? That means 2 power 3 divided by 2 times 2 times 2 times 2 times 2. In the same way, using cancellation rule, you could find this 2 is cancelling here, similarly here, the same as here. The numerator part is giving us 1, while the denominator is giving us 2 exponent 2. Now, what is the conclusion behind? It means we simply conclude that in approach 1 and 2, they all signify the same result, which is the same as to say 2 power negative 2 is the same as 1 over 2 power 2. So we say thus 2 power negative 2 is the same as 1 over 2 power 2. This one is the same as to say when one would be taking 4 power negative 8, when putting reciprocal 1 over, it will result as 4 power positive 8. So we say generally we say a power negative m is the same as 1 over a power positive m. This is one of the most important rule also, class. And we'll be using this rule to work with some challenging questions leading to solving equations which will be involving multiple concepts of exponents. Now let's check again rule number 5 here. Rule number 5. Here I'm going to pose by question form. We say find 2 power 3 power 4, let's say. Class, how can you approach this question? Can you use any concept relating with rule number 1 to treat this one? How can you do this question? Checking carefully, you will realize that here we could come with the rule we call the law of power. The law of power. How it works? It means just finding the question which is raising 2 power 3 bracketing power 4. One could treat as per body mass rule. Here we say we treat as per body mass rule. How body mass works? It says start with bracketing. It means here when we have 2 power 3 power 4, one could take 2 power 3 times 2 power 3 times 2 power 3 times 2 power 3. We have taken 4 parts, but which all takes 2 power 3. So if you check carefully, class, you will note that 2 power 3 will have also to be expanded 2 times 2 times 2. But we have another group, 2 times 2 times 2. In the same way, 2 times 2 times 2. And the last portion again, 2 times 2 times 2. When counting all 2's from the beginning of the expression up to the end, it will be giving you the result, which is 2 power 12. When you check this 12 here, you will just notice that it was simply as to take 3 times 4. Yes, so we say it follows that 2 power 3 bracket power 4, it was simple as 2, 3 times 4, which is the same as 2 power 4 times 3. We interchange here simply because the multiplication is commutative. You can reverse the order, but still maintaining the result. So here we say, thus, wherever there exists a power m, a power n, let's say, bracketing power m, we will simply take a power n times m. It means multiplying numbers with two exponents at the top. We will simply multiply the exponent, take the base maintained. This is one of the most important rules also in exponents. Having said that, class, we are now able to solve some problems relating to exponents. Now let's check here. We say worked examples. Worked examples. Worked examples. One can give us solve for x given that 3 power 2 x plus 1 minus 10 power 3 x plus 3 equals to 0. You can remember this was a national exam. That was 2018, if you remember, Advanced Mathematics paper 2. This question, to solve this question, which involves the part of exponents, you will just proceed like this. So here we say solution here. First of all, you'll have to recall this rule. We say recall a power m times a power n is always a power m plus what? Plus n. In the same way, when checking this part 3 power 2x plus 1, it signifies that previously it was simply as 3 power 2x times 3 power 1, and then minus 10 power 3x plus 3 equals to 0. Yes, look here, class. We have just separated this part, a part which is taking the single exponent 3 power 2x plus 1. That is why 3 power 2x plus is the same as to take 2x plus 1, so taking the single base. So we have maintained the concept. And then checking from here, we say recall again. When we have a power n power m, this is a power n times what? M. That is from rule number 5, the law of power. Similarly, when you check here 3 power 2x, I can write like this. 3 power x bracket power 2. It means x times 2, then 2x. The 3 power 1 is 3. So I can put 3 here. And then minus 10, 3 power x, and then here plus 3 equals to 0. With this class, we always want to make settings. So we say setting 3 power x, set it as a. We will just have 3 power a square. We have made the entire expression, call it as a, minus 10 a plus 3 equals to 0. Now this is a simple quadratic equation in which the word quadra, taking the exponent of 2, we could be solving this by splitting the middle term. Splitting the middle term, you'll find 3 times 3 is 9. So numbers switching for splitting is negative 9 and negative 1, which is true. So here we'll be taking 3a square minus 9a minus a plus 3. Factorizing here, grouping the two terms, 3a outside is a minus 3. Take negative 1 outside is a minus 3 also. So we are taking these outer parts. These ones will simply give us 3a minus 1 and a minus 3. Using the properties of real numbers, it signifies a is 1 over 3 or a is 3. Class, mind you, our intention was not to solve for a. Our question was containing the variable x, but upon making some setting, we have now come upon with a, we will always have to make replacements. We say, but we know that 3 power x is a. We say, so 3 power x equals to a. The first a is 1 over 3, and 3 power x again gives 3. So I can put supportive exponent here, 1. Any number power 1 is the same number. We have not changed the concept. And again, taking from negative exponent, you will take 3 power x equal to 3 power negative 1. This is from 1 over 3. In the same way also, 3 power x is the 3 power 1. So here we say equate the exponent. Equate the exponent. Do not make cancellation. Do not cancel here, my friend. Just equate the exponent. If you make cancelling like this, that is awkward. It's not mathematical. You just have to write the word equate the exponent. A reader will know that you are taking the upper part, leaving the base. So x equals to negative 1 or x equals to positive 1. Now these are the results, negative 1 and positive 1. These are the results from this counter example. Now let us check question number 2, where one is asking us to simplify. Simplify completely. Simplify completely, one can give us a question like this class. 1 over 2 x power half, open brackets, 1 minus x power negative half, and here we can have plus x power negative 1 over 2, 1 minus x power positive half, and here divide by x square. Okay. To simplify this counter question class, you might be intelligent enough. The simplest way to do this question, when you come across with a counter question like this, just check the nature of the exponents. For example, you will see here there is x power positive half, while here there is x power negative half. It means here the trick is to introduce this, we call it cancellation factor. A cancellation factor is a factor you introduce without affecting the expression. So for example, look again here, 1 minus x power negative half and 1 minus x power positive half. There is another base which appearing the same but different exponent. So here we treat like this. We say solution in this, we write 1 over 2 x power positive half, open bracket, 1 minus x power negative half plus x power negative half, open brackets, 1 minus x power positive half of the entire expression x square. So here the best way is to introduce these capital brackets, where we have seen, since you have x here, introduce x power positive, and then also here x power positive. We have not changed the meaning. It is easy to cancel this x power half, but we are not cancelling. We have some intention, purposely, mathematically. So I'm going to take this x, avoiding body mass, avoiding brackets, I mean, x power half times x power half. It means we are taking that rule, multiplying the number of the same base, add the exponent. So x power half times x power half, it means a half plus a half will give you 1. Then you are going to have x power positive 1, which is just 1 over 2 x, 1 minus x power negative half plus x power half times x power negative half. You will be adding the exponent. Positive half plus negative half is 0. So x power 0, any number power 0 is 1 from our rules. So it's just the same as to say there is 1. No need of just writing 1. We just write 1 minus x power a half. And here the denominator will appear as, our denominator here will appear as x power 2 times x power half. You sum 2 plus a half is 2 and a half, which is 5 over 2. So is x power 5 over 2. Again, you set another capital bracket. purposely. Then here you check. There is 1 minus x power positive half. Introduce again denominator. 1 minus x power positive what? You also, we have also not changed the concept. Cancellation, this factor can cancel. But mind you, we don't cancel it. Purposely, we want to go somewhere. So, using the same rule as above, when you take 1 minus x power half times 1 minus x power negative half, we are going to maintain the base, but we will add the exponent. A half plus negative half is 0, and an upper power 0 is 1. So the entire expression will remain as what? Will remain as 1 over 2 xc, because this expression will become power 0, which is 1 plus this much times this one. Now we are going to have 1 minus x times 1 minus x. So power half, you will take a half plus a half, which is positive 1. So it will remain as 1 minus xc. 1 minus x, very good. This is 1 minus what? Minus x, put x here. And then the denominator will remain what? Our denominator will remain x times 1 minus x power what? Power half. And then here, operation algebraically, a half x minus x is simply as a negative half. So it's 1 minus 1 over 2x. And the denominator is what? X, 1 minus x power 1 over 2. So you can see, class, this is completely simplified, and you cannot simplify beyond this. Okay. I could not offer beyond this with the part of exponent. We are taking a short break. Thank you for listening. We will be coming back. Don't go away. Thank you very much.